Yo, 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 yo! What is up, everybody? It's Mr. G here. We're going to talk about making inferences from a random sample. So at this point, you should know what a random sample is, what a population is, okay? And then what we're going to do is we're going to talk about how do we use that information from that random sample? Like how can that help us make predictions? So first, we need to know what an inference means. An inference is a conclusion or opinion that is formed because of known facts or evidence. So what we're going to do is we're going to find a random sample, and that's going to be our facts or evidence, and then we're going to make a conclusion based on that, what we find from that random sample. So that's going to be making an inference. So you'll see when we get there. But first, we're going to learn how to make a box plot. So the number of pets owned by a random sample of students at Park Middle School is shown below. Use the data to make a box plot. So random students were surveyed at Park Middle School, and this is the amount of pets each one of those random students had. So one student had 9 pets, 2, 0, 4, 6, 3, 3, 2, 5. So first we want to order the data in order from least to greatest. So looks like the student who had 0 pets, that's the least. I'm going to cross that off. Ordering from least to greatest is required. This is not optional. If you do not do this, you have no chance to be successful in this. I have another 2 over here. Notice how I'm crossing them off as I go. Looks like I have 2 3s. Bam, bam. Then I got a 4, 5, 6. 4, 5, 6, 4, 5, 6, and then last but not least, 9. And then just to double check to make sure I didn't miss any data points, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I reordered my data from least to greatest. So now I'm going to find the least value, find the upper and lower quartile, and I'm going to find the median. So first, here's my order again, and so I'm just going to fill this in here because it's already broken everything down for you, but we're going to talk about what everything means here. So there's the order of my data from least to greatest. Again, I just rewrote it in these boxes from least to greatest. So what we do is if we want to find the quartiles, okay? So first, we know our least value is going to be 0 and our greatest value is going to be 9. That's the easy part. The lower quartile and the upper quartile, it's not like it's that difficult, but it is important. So what we do is first we always have to find our median. So our median is our middle number. So if I'm looking for the middle number here, if I go 1, like what we've done with the dot plots where we go off to the sides here, and I'm just showing it, this is one way to do it. So I've got my middle number of 3 here. So here's my median of 3. So I'm going to write median in the box. My median is 3. Now, what we do is now that we have our median, we have our lower half of our data and we have the upper half of data on each side of the median. So this is my lower half. This is my upper half. Or this is my lower half, this is my upper half. What we're going to do for the lower quartile, you're just finding the median again, but you're just finding the median of the lower half of your data. So I'm trying to find the median of just these 4 numbers. I'm trying to find the middle number here. So notice how we have a box around these 2. The reason why is because there is no middle number exactly. I have 2 numbers that are in the middle. 2 and 2, because those are the 2 middle points. It's an even amount of data points, so therefore we're going to have 2 numbers that are in the middle. Well, you're going to find for the lower quartile is the median of this. I mean, it's just the average of these 2 numbers. Well, the average of those 2 numbers of 2 and 2 is just 2. So I'm done. I don't have to do anything. But if this was like, just for example, we'll show you on this side on the upper quartile. So now for the upper quartile, again, I'm looking for the middle number. Well, there is no number truly in the middle because I have an even amount of data points. I have 4, 5, 6, 9. So I'm finding the average between 5 and 6. So for lower and upper quartile, again, let's start from the beginning. I feel like I went too fast through that. Remember, if you need to pause it, if you need to rewind, pause it and rewind. So first we found our median. Once we find our median, we have our lower half of the data, we have our upper half of the data. So then what we're going to, then for the lower quartile and the upper quartile, we find the median of just the lower half and the median of just the upper half. Well, the median of my lower half was 2, so that's why my lower quartile is 2, because that's the middle number. That's the average of these two middle values. To find the median of the upper quartile, so we're working with the upper over here, is I'm going to find the average of these two data points because both of these are right in the middle. Right? If I were to, because I have 1, 2, 3, 4 data points, my middle number, well, there's nothing in the middle here, so that means I got to find the average of these two. Well, to find the average between 5 and 6, it's 5.5. But the way we do that is find the average of anything, you just add them up and divide by however many you just added up. So 5 plus 6, I added 2 up, so I have to divide it by 2. So that's 11 divided by 2, which is 5.5. And I should also know that 5.5 is halfway between 5 and 6. And then I have my greatest value is 9. So by doing this, by finding our lower quartile, median, and our upper quartile, this is our box, right? We should know at this point that the first line of the box is the lower quartile, the second line of the box is the upper quartile. I mean, the outside of the box is the upper quartile, and then the middle in between is the median. And then we always have our lowest value and our greatest value to show the whiskers. So then from here, I can actually make my box plot. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we do is we now just plot our points above the number line. These are the 5 points we plot. I have 0, 2, 3, 5.5, and 9. Do the whiskers from the outside first, and then you just get to make your box. And then there's your median. So that's how you make a box plot. Start with your median, order from least to greatest, get your median, and then median of the lower half, median of the upper half. Now, we're going to come back and look at this information. You'll be able to just look at it on your paper. I got to come back and forth to answer a few questions. So we're going to draw some conclusions based on what we just, the data, the random sample we collected, and then the conclusions we're going to make based on that data. So a good measure for the most likely number of pets is, this is where we're going to use our median. So a good measure for the most likely number of pets is the median, which would be 3. So the median is a really good measure to use. And for this one, it means 3. Okay, so the median would be a good measure to use for the most likely number of pets. It's the middle number. And then we're going to say that the middle average amount of pets is 3. 50% of students have between blank and 3 pets. Well, if the median, this is the middle number, right? So this is our middle value. That means 50% would have between 0 and 3 pets, because this would be half the data. The other half would be this way. So 50% of students, because we cut it in half, because this is the middle, so that means this is 50%, this is 50%. So 50% of students have between 0 and 3 pets. Almost every student in Parkview has at least, well, let's see, of all of our 9 data points, we only have one person say 0, so I would say at least 1 pet. And there we go. Those are our conclusions that we made based on this random sample. Now, did this student have any opportunity to talk to every single student? No, but based on this random sample, these are the conclusions they've made. That the most likely number of pets a student has at this middle school is 3. That about half the students are going to have between 0 and 3 pets, and almost every student is going to have at least 1 pet. Okay, another way to draw conclusions from a random sample is we're going to have to use proportional relationships. So here's how. Here we have a shipment that consists of 3,500 MP3 players. So let's just call them iPods. You guys probably don't even know what an iPod is or an MP3 player is. Or you might, who knows. But they have a shipment company that has 3,500 MP3 players. The manager chooses a random sample of 50. So of this 3,500, they start opening up boxes and they find 50. And they determine that 3 of those 50 are defective. 3 of them aren't working. So now they're going to use this random sample. They took a sample of 50 just to see how they worked. Randomly took 50 out of the 3,500. Found out that 3 are defective. And then they're going to use that to determine how many MP3 players in the whole shipment are defective. So here's what we can do. We know we're going to write a ratio, number of defective over the total. But we're going to do this with our sample and with our with our population. I'm sorry. And we're going to set them both up the same. So if I have number of defective over the total, in our sample, the number of defective were 3 out of 50. Well, in our population, I don't know how many are defective. That's what we're trying to figure out. But I do know the total. There's 3,500. This is my proportion that I can solve from here now, that I'm trying to solve. And the way we solve, again, we've seen these before, is where we have to cross multiply. So I do 50 times x. 50 times x equals 3 times 3,500. 3 times 3,500 is 10,500. And then I have to divide both sides by 50. Now, this is where calculators are nice, right? I don't want you guys getting caught up on doing the division. I want you to do the calculator. I want you to let that do that part of the work for you, so you just are worried about setting it up correctly. And I'm trying to plug it into a calculator right now. So I have 10,500 divided by 50. So by this, the prediction is we made a prediction that 210 of these 3,500 MP3 players are going to be defective based on this random sample. So we know 3 out of every 50. So therefore, if I know that 3 out of every 50 are going to be defective based on this sample, then I'm going to multiply that till I get to 3,500 to figure out 210 out of 3,500 are probably going to be defective. Okay, I want you to try one on your own. And when I say try it on your own, I mean actually try it on your own. Okay, and you have this what if right here. Okay, so using the same scenario, how many MP3 players in the shipment would you predict to be damaged if 6 had been damaged versus the 3? So try it on your own. Come up with an answer. Okay, so hopefully you pause it and you have an answer already. If you don't, pause it. Come up with an answer. I know 6 out of 50 are defective. We can set that up as x out of 3,500. So again, I cross multiply. So I'm just multiplying. So I know this is going to be 50 times x. And I also know this is 6 times 3,500. Now is where I use my calculator to do 6 times 3,500. So 6 times 3,500 is 21,000. Now I know a lot of you guys took a shortcut on here, but this is for the people who didn't take the shortcut. And I'll show you the shortcut after we finish it. Now I get to divide both sides by 50 to get x by itself. And I get 420. Now the shortcut for this, I just want to show you the long way just so we can see that process again. But the shortcut would have been, if we figured out that it was 210 for 3 out of 50, well, isn't 6 just double that? So that means the amount of defective in the whole shipment would have also been doubled, which 210 times 2 is 420. So some people might have just realized, oh, so it's just got to be doubled because we're doubling the amount of defective. So cool. That's it, guys. That's all. So for your things to remember, lower quartile is median of lower half. Of data. And then I also want you to write upper quartile is median of upper half of the data. So get those two things. That's all I got for you guys this morning. Or not this morning, but that's all I got for you guys today. You might be watching it in the evening. You might be watching it in the afternoon. So, but that's all I got for you. I hope this helped. If you have any questions, please let me know. Good to see you out.